All right, first question asks, write the statement as a biconditional. Okay, when we hear biconditional, we should be thinking the if and only if statements. Okay, the statement is congruent angles have equal measure. And basically what we need to do here is just take the two things we're talking about, congruent angles and have equal measure, and stick an if and only if between them. So I could say that angles are congruent if and only if they have equal measure. Okay, so angles are congruent if and only if they have equal measures. Now with this one, I could have also done it in the opposite order. I could have said angles have equal measure if and only if they are congruent. Okay, but we'll stick with the option on the Kahoot and say that's the right answer. Next question says to make a biconditional statement, if possible, from the following conditional statement. So remember, biconditional just means our if and only if statements. Okay, so we want to write if and only if statement. And this one says if possible because it's not always possible to go from a conditional to a biconditional statement. Basically, we need to check and see if the conditional statement is reversible first. Okay, so this one says if an angle is a right angle, then it measures 90. We'll say that's true. Now let's look at that in the opposite direction. If an angle measures 90, then it's a right angle. That's also true. So since it's reversible, I can write a biconditional statement. We'll say an angle is a right angle. Okay, so instead of the if, we'll just say an angle is a right angle. And then instead of the then, we'll say if and only if. Okay, it measures 90 degrees. Okay, so an angle is a right angle if and only if it measures 90 degrees. Again, biconditional is that if and only if statement. And you could also do this in the other order. If an angle measures 90 degrees, an angle measures 90 degrees if and only if it's a right angle. Okay, biconditionals work in both directions. Next question says, give the two conditional statements that make up the biconditional. Okay, remember, biconditional is our if and only if statement. And the bi in that means two, okay, two conditionals. So anytime I read a biconditional, there's two if-then statements that biconditional is telling me. So my biconditional says that two angles are supplementary if and only if they add to 180. And what I can do is I can make two conditionals out of that in either order. One would be if two angles are supplementary. Okay, then they add to 180. Okay, so that's one of my conditionals, and then two, the other one would just be the converse of the original conditional. Okay, this biconditional in reverse order, we'd say if two angles add to 180, then they are supplementary. Whoops, then they are supplementary. Okay, so biconditional, two conditionals. Anytime I read a biconditional that's true, I know I'll have two true conditionals from it in either order. Next question asks, which statement is a good definition? Okay, so I have 4 statements here. I already have the good one highlighted, but let's go through why the other ones aren't good definitions. The big thing we said for a good definition is that it's reversible, that it works in either order. So let's think of the first one. Squares have right angles. Now that is a true statement, but I'm going to say it's not a good definition. If I think of it in conditional form, it's not reversible. I could say if a figure is a square, then it has right angles, which is true. But if I reverse that, if a figure has right angles, then it's a square. That's not true. There's a bunch of counterexamples of that. Okay, so that's why that one's not a good definition. Same thing with the blue option, redwoods are large trees. Again, if it's a redwood, then it's a large tree. That's true. But if it's a large tree, then it's a redwood. Okay, not necessarily true. There's other large trees. Okay, fire is hot to the touch. Again, if it's fire, then it's hot to the touch. True, but if it's hot to the touch, then it's fire. That is false. There's other things that are hot to the touch that are not fire. The green option works because we could say if a figure is a triangle, then it has 3 sides, which is true. But also, if a figure has 3 sides, then it's a triangle. That is also true. Okay, so we'd say that this definition is reversible. That's why it is a good definition. So next question says, draw a conclusion, if possible, from the 2 statements. And we're given the conditional, if you get a good night's sleep, then you will have energy in the morning. And then also, Becky has energy in the morning. I'm going to say that there's no conclusion possible from these 2 statements here. Okay, why is that? Well, this Becky has energy in the morning, we could say doesn't satisfy the hypothesis you get a good night's sleep. Okay, now if we said Becky got a good night's sleep, we could make a conclusion. We could move forward in that conditional chain. But I can't move backwards. I can't go from conclusion to hypothesis, only from hypothesis to conclusion. If you think about this logically, there's other reasons we could have energy in the morning, drink a lot of coffee, just a morning person naturally. Okay, so moral of the story is to make a conclusion about Becky, what she does has to satisfy the hypothesis, which it doesn't, and I can't work backwards through these conditional statements. Next question, draw a conclusion, if possible, from the 2 statements. And here I'm given the 2 conditionals. If you like cheese, then you'll like pizza. And if you like pizza, then you'll love calzones. Okay, I'm going to say I can chain these 2 statements together because you'll like pizza and you like pizza are the conclusion and hypothesis of 2 conditional statements. So what I can do then is I can basically skip the like pizza part in the middle and make the conclusion, if you like cheese, then you'll love calzones. And again, I can do that because my conclusion of one statement matched the hypothesis of the other, so I can go straight from hypothesis to conclusion. All right, next question asks, which conclusion is incorrect? So I have some statements here, some conditionals along with just another statement. If you do all your Math Excel, then you'll pass the quizzes. If you pass the quizzes, then you'll pass the test. And also, Timmy did all his Math Excel. Okay, we can see which ones work and which one doesn't work here. Let's just go through why each of these work. Timmy will pass the quizzes. I can say that's true because Timmy did all his Math Excel. And doing all your Math Excel means you will pass the quizzes. Okay, so we'd say Timmy satisfies the hypothesis of that conditional. Therefore, we can make the conclusion about Timmy. Okay, next one in blue, Timmy will pass the test. Yep, that is true. Since I can make this conclusion about Timmy, he passes his quizzes. He also satisfies the hypothesis for will pass the quizzes, so I can say he will also pass the test. Okay, in yellow, we can chain these conditionals together. If you do all your Math Excel, then you'll pass the test. Okay, here again, since the hypothesis of the conclusion of my first statement matches the hypothesis of my second, I can go straight from hypothesis of the first to conclusion of the second. Okay, the last one in green, that one's incorrect. If you pass the test, then you did all your Math Excel. Again, I can't work backwards through these conditionals. Okay, we're not going to assume that they're true in reverse. We're not going to assume the converse is true. Okay, so there's no working backwards through them. Only forward.